My name is Avidan. I'm from K2 Networks. And I want to talk about a concept called contextual agentic garbage collector. You can think about it as a smart sweeper that sweeps misconfiguration crumbs before attackers can even get a chance to exploit them. We'll start with describing the problem space, then move on to the detection layer, and finally present the agentic framework that allows this to happen. Before we do that, just one word about us. We are K2 Networks. We're a company in the SASE space, the convergence of networking and security. Our platform actually takes all of the customers' network and security infrastructure and moves it to a private backbone that spans all across the world, our own private backbone. And it actually allows all the customers to enjoy one unified system that they can manage all of their security solutions over our cloud infrastructure without having all those security appliances that are still being sold today by many companies. So let's talk about the problem space a bit. In 2023, Gartner have said that by 2025, 50% of all security incidents will occur either due to human failure or lack of talent. And if that number isn't concerning enough, you can add it to the almost 4.8 million unfilled cybersecurity roles across the industry, and the pressure on IT teams across the world is skyrocketing. But you can say, wait, but AI is replacing everyone, so why is there such a high number of unfilled cybersecurity jobs? Well, the shortage didn't really disappear, it just shifted. So we can actually see that the shortage shifted up the skill ladder rather than disappeared. So if in 2020 companies were looking for security analysts, you will now see companies looking for security engineers. We need people to actually know how to use AI to protect the infrastructure and not use AI by itself to protect the infrastructure, just as we need software engineers to, how did you say in the last session? Babysit Rolf, right? So this is like the same with security engineering. So it means basically that automation and AI are no longer optional. They're essential for survival. You will see that in the next slides by the amount of context that exists inside security policies and security products. And it becomes essential for survival. So our users are basically IT administrators, and they configure their desired behavior on our platform using policies. You can see policies across many security products, even on security appliances, and you can see policies also on AWS. It exists all across the industry where you need to set rules for a certain behavior. So essentially, a policy is comprised with a set of rules with multiple configuration dimensions like to, from, and a certain application or service, etc. And while policies are so powerful and impactful, a single misconfigured rule can introduce serious security and operational risk. You can think about it as the human failure that we've discussed on the previous slides. Basically, this policy is comprised by humans, and a single misconfiguration can lead to an incident. So we basically decided to bring together two worlds, the world of policies and the world of AI. With this convergence of these two worlds, we were able to detect new kind of findings and insights from detecting contextual misconfigured rules, like a certain rule that is misconfigured, all the way to suggest policy-based optimizations when the policy itself, not just a single rule, is misconfigured. So it's actually, if we look at how policy looks like, it's not just the dimensions like the source, the device, the app or category in the service and the port. There is also metadata around the policy, around the rule. You can see the name of the rule, you can see a description of the rule, and where is it located inside the policy. So the order of the rules actually matters. So our agent is actually applying contextual misconfiguration detection. It can examine elements such as the rule name and description, the associated tickets, contracts, wiki pages associated with the rule, etc. And customer customized documents also. It takes a lot of the heavy lifting off the customer's shoulder. So in the next few slides, I'm going to present some examples for temporary rules, testing rules, and expired rules. But there are also contradicting rules, mismatch rules, and over-permissive rules. And these are the rules that are relevant for the policy level misconfiguration. So these are rules that are misconfigured by themselves. And the last set of rules are actually policies that are altogether misconfigured. Think about two rules that actually contradict with each other. So which one is right? Like, which one should actually work? So let's see some examples. So temporary rules are rules for short-term solutions designed to address immediate, often business-related needs. You can see an example here. It says allow unlimited access for R&D. The description says required temporarily for the 2025 hackathon event. This is a temporary rule. It should not exist after the hackathon was ended. You can see temporary allow inbound connection for RDP. RDP is remote desktop protocol. And if you know how many CVEs, like vulnerabilities, have been discovered in the past few years around RDP, leaving an RDP port open without a reason is extremely dangerous. So if it was requested temporarily to test something and it's not needed anymore, it should be removed. And often, if something like that has been configured, nobody remembers to remove it. If you've configured a policy in your life, you probably know it. And there's another one here. Make sure that an app can have any connections as a third-party contractor asked. If the third-party contractor does not work for the company anymore, the rule can be removed as well. There are rules here that are not in English. I think this is Spanish. And if you're using an LLM and the context is clear, so it doesn't really matter which language it is, the LLM can pick it up. And you don't need to configure any static rules to catch that. Because one can say, OK, I will just run a quick search over all the descriptions and search for TMP or temp, like a word. But it's not that simple. You can see here rules that are being considered as temporary just according to the context and the language around the rule name and the description. Using just statically looking for the word TMP will not do. Let's move on to testing rules. The rules that were set and created for validation, debugging, or experimenting with a specific feature or a scenario. So you can see here, troubleshooting a network issue applied only during a debugging phase, over permissive. Now, we all know how generous we are when we're debugging something, right? And if you need a policy just to see that debugging is work, you can be very permissive with the rules that you're asking your IT to configure. But if they left it there and it's not needed anymore, it should be removed. Another rule that says allow any rule to see the potential impact. Allow any in policies means that basically anyone can access anything, right? So if anyone can access anything, what do we need a policy for? It basically cancels the entire idea of having a policy because everything is allowed. So if anyone forgot a rule like that in their policy, it's a major security issue. Another one used for quickly check if the latest IP cameras communicates the DVR server issue were resolved. If it was resolved, we can remove it. And another few examples in Chinese, French, and Spanish. All the context around these sentences was around testing. The last example is expired rules. Basically rules that were set to expire at some point in time. We can think about rule descriptions that indicate marketing course ends on July 21st. We can see another one that will expire in the rule name by the 13th of May. And we can also see examples where there is no specific date. There might be an event like Easter. Okay, you can remove it after Easter in the rule description. If you would look like for a specific pattern of dates, you wouldn't really find it. So static analysis cannot work here. Contextual analysis, however, can work. So what do all of these AI insights on the policies have in common? They both improve two metrics. First one is the detection quality, and the second one is the detection speed, the mean time to detect. And remember earlier what we said about how many incidents will occur due to errors like this. So if we detect it very well and it takes less time to detect it, we've done great success. So let's see how this agentic framework actually works. So to enable it, we started off with configuring an agent that is called an orchestrator. It's responsible for triggering the analysis and control basically all the other agents. It can ask for human-in-the-loop verdict, and it stores and publishes all the results to production for the customer to act upon. We have the data retrieval agent. Basically, this policy that we're looking at exists somewhere. We need to retrieve the data of the policy. So it fetches the data, and it can check also for available enrichments from third-party sources. We've seen examples in the rule descriptions for certain tickets. So the tickets can be enriched via ServiceNow or Zendesk, where the company is managing all their tickets. It can use an LLM to distill the most relevant points from long text, generate summaries, and perform name and entity recognition. Then we have the temp rules detection agent, which is responsible for detecting the temporary rules. It's using a Anthropic Claude 3.5. It was developed last year, so we can improve the model here and use a new one. But the first version was developed with Claude Sonnet 3.5. And it is capable to investigate further to confirm or disapprove low confidence insights by querying internal systems such as contract management platform or ticketing systems like Jira or Wiki. And it provides the output in an agreed format. Then we have the expired rules detection agent, which is responsible for detecting the expired rules. Two tools that it has that are relevant. First one is the time function that is helping it to actually understand if a certain time, a certain date has passed. And the holiday and events resolver. So if someone said Easter, we need to understand if Easter have already passed this year or not. And also, it outputs according to an agreed format. And the judge agent, which takes basically all of the results and responsible to make the decision. It's also using Anthropic Claude 3.5 Sonnet, and it's also capable to perform noise reduction to tackle high ambiguity alerts. And if there is, let's say, a conflict between one agent to another, let's say two agents have said two different things about a certain rule, so it can actually perform and solve the conflict. So let's connect all of them together. We have the supervisor agent that calls the data retrieval agent, which then retrieves the data back to the orchestrator. The orchestrator executes the detection agents one by one with the relevant data. The results are sent back to the orchestrator. The orchestrator sends it to the judge agent. And with the judge agent, we can send the results to production. So I think that's about it. So basically from a problem to a solution, we've shown how we can apply AI on security policies, on the data behind the policies, and reduce the time it takes to solve the policy and actually reduce the attack surface. Thank you very much.